Hi, so today we are going to be talking about probability, and we're going to start off with combinations and permutations. So before we get into combinations and permutations, we use what are called factorials. So I just want to go over what factorials are. So a factorial is a product of all positive integers less than or equal to n. So if we have 5 factorial, so we use an exclamation to represent a factorial. That means we would multiply 5 times 4 times 3 times 2 times 1. If it was 3 factorial, we would multiply 3 times 2 times 1. Okay, so now that we know how to use a factorial, we can jump into combinations. So combinations we use to find the number of possibilities when order does not matter. And the formula to do this is we do the total factorial divided by the number that we choose, factorial, multiplied by how many are left. Factorial. So let's say Emma has 8 markers and selects 2 markers. So to figure out how many different ways she can select 2 markers, we are going to first put the total of markers she has, which are 8 factorial. Then we're going to divide that by how many she chooses. So she is selecting 2 markers. So we're going to write 2 factorial times how many are left. So if she has 8 markers, she picks 2, there are 6 markers left over. And then we are just going to expand and simplify. So 8 factorial, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 2 times 1, that's 2 factorial, times 6 factorial, so 6, 5, 4, 3, 2, 1. And then we're going to need to cross off 1s to simplify. So our 6s, 5s, 4s, 3s, 2s, 1s all cancel each other out, which leaves us with 7 times 8, which is 56, divided by 2, which is 28. So there are 28 combinations of markers Emma can choose. Okay, so let's look at your assignment on combinations. And you'll see pretty much what we just did in our notes. So here's the problem. A teacher is going to select 3 students from a group of 10 who do not have to take that day's quiz. How many ways can the teacher select the 3 students? So does order matter? Why or why not? So does it matter if she picks student 1, 2, and 3 don't have to take the test, or if she selects student 3, 2, and 1? Either way, they don't have to take the test, students 1, 2, and 3. So order does not matter. Versus 3, 2, 1 doesn't make a difference. Okay, and then here's our formula again. So for this problem, there are a total of 10, right? So there were 10 students, and then she was choosing 3. So it's 3 factorial, and then however many are left, which is 7 factorial. So then we expand our factorials. These all cancel out, leaving you with 10, 9, 8 divided by 3, 2, 1. And then you simplify, which means there are 120 different variations of 3 students the teacher can pick. We'll do one more. So Allie has 5 friends. For her birthday, she can take 2 of her friends with her to Disneyland. How many combinations of friends can she bring? So we're going to use this formula up here. So the total, she has 5 friends. So that's 5 factorial divided by how many she can choose. She can take 2. So that's 2 factorial. And then how many friends are left? After she picks 2, there are 3 friends left. So 3 factorial. So we have 5 times 4 times 3 times 2 times 1 divided by 2 factorial. 2 times 1 times 3 factorial, which is 3 times 2 times 1. 3's cancel out, 2's cancels out, 1 cancels out. So we get 5 times 4 on the top, which is 20, divided by 2 times 1 on the bottom, which means there are 10 different combinations of friends she can bring. Does order matter? Say she has 2 friends, Jack and Jane, that she picks. If she picks Jack first and then Jane to go to Disneyland, does it matter? Is there any difference between her picking Jane and Jack? No. So order does not matter. Okay, so you're going to complete your combinations assignment. So there's a couple more practice for combinations.